हेलो एवरीवन। समोसा जो खाया था पच गया है। इंफॉर्मेशन डाइजेस्ट हो पाएगी और नहीं हो पाएगी? हो जाएगी, हो जाएगी। नाइस नाइस नाइस। सो मिनिमलिज्म, ये कीवर्ड मैं टॉक में शायद 100 बार ही बोलूंगा, तो बियर विथ मी। बट हाँ, I'll give you the idea of how, like, why minimalism is important in cloud security and how potentially it can help you prevent attacks from the future itself. So look forward to it. Bit about who am I? Satyam already introduced me, but I work as a software engineer at Accuknox, maintaining and leading the KubeArmor project. It's a CNCF Sandbox. I'm a CNCF Ambassador, and I'm actively mentoring over Google Summer of Code and Linux Foundation Mentorship. Containers, we have been learning about containers from the morning. I will not go into like what's a container, but something we have not talked about yet is container security. So how do we implement security and how do we think about container security? So this is a standard Kubernetes cluster. We have nodes, we have containers. A node, it have its own kernel, it has its own system packages, container runtimes. But due to this large surface area, there are always attackers looking at it. ठीक है यार, कुछ तो gap मिले, I'll attack it. And as an attacker, I always want to gain information out of your cluster. And the dashed dots are for a reason that, okay, there are a lot of vulnerable points in your cluster. So how do we reduce them? How do we reduce the surface area? You can try to reduce surface area at lot of levels, even the node, even the kernel, the system packages, the container itself. And the end goal is कि attacker का चेहरा ऐसा हो जाए कि हाँ भाई, कहाँ attack कहाँ करूँ कहाँ मैं. So we'll start with like that's the approach that I wanted to take, is how being minimal with your choices of node, container, kernel, system packages can affect and help you out with the security itself. To start with, we'll go with node images. Node images is like, अगर कभी Kubernetes cluster बनाया होगा, तो like it asks you कि whether you want to use Ubuntu, whether you want to use RHEL. There are a lot of node images out there. If you have set up your clusters on your own virtual machines, then your host itself is the node, it's kernel itself. There are a lot of minimal node images out there. Something like container optimized OS by Google Cloud, bottle rocket by AWS, Azure Linux. It's not much advertised, I guess, right now, but it's also somewhat secure, and Rancher OS. So all of these are meant and meaningful towards the minimal that contribute to these minimal node images. But why do we need this minimal node images? As we understand, containers already package all their dependencies themselves. So you don't really need all the system packages that you have here, because containers are not at the end using system packages. They just go through the container runtime and directly dock to the kernel. There's no dependency on these system packages. So what these node images do is they reduce the things at a lot of levels. To talk about them, they have an immutable root file system. At the root file system layer, nothing can be modified in general. So that helps contribute to security. Reduce system bloat. As I said, containers already are packaging all the dependencies. So there's no need for your node to have its own system packages as well. So that's where those come in. And it has a hardened kernel. There's some features like integrity measurement architecture, secure boot. But you might say, ठीक है, so many features out there. How actually are they helping me out? Why are they? What are they doing such that they are helping me out? And I'll invite Rocky Bhai to help me here. So not Rocky Bhai in general, but I'll talk about Rocky Malware. Rocky is a Chinese team. They had developed a malware back in 2018, I guess, which helped with crypto mining attacks on your Kubernetes clusters. What they did was it was a 3-step process. They had self-replication. They wrote to temp folders, copied it to some SBIN directory. There are some detection engines out there which say that, okay, this was modified. But what they did was they altered the timestamp itself to say that this image was created 416 days back. So your detection engines fail as well there. Then they compiled some like arbitrary malicious code using GCC on your node itself and installed GCC if it was not installed at all. And finally, they modified the boot systems to inject some service so that this malware can automatically start on your boot. So how does minimal node images help us here? We have an immutable root file system. I talked about immutable root file system. So the temp directory itself, even if we can write to temp directory, it cannot be copied to user SBN directory at all. So you are very free that even if someone tries to do this, it's not going to be able to happen. Similarly, the object file injection would not be possible because GCC is not in your system. And something like container optimized OS, it does not even have an apt install or something like that. You cannot install third-party packages at all. So that's why you maintain your file integrity and you are safe that, okay, nothing is going to be modified. And finally, because we talked about integrity measurement, architecture and secure boot, your boot service itself is also secure. So the binary, even if it would have been copied, it would have never started itself. So that's how just choosing the right node image prevented you from an attack. You did not even need to configure anything. So that's the approach we took for nodes, but there's still a large surface area left. That's our containers. We talked about the node itself, but what about the containers itself? Are containers a black box that we don't need to worry about? That's a common misconception that we have, that containers are a black box and anything happening inside that, I as a user don't need to care about that. So what we do is, what we don't understand is that this container itself has access to a lot of things. In the last talk, we talked about how a container can talk to other containers from other pods. It's going through VETH, ETH, like bridge devices. So in general, if you understand, as a container, if I send out a packet, I'm able to traverse the entire network stack altogether. So that exposes a lot of surface area to my container itself. So what if these entities inside containers turn malicious someday? I don't know. They will have access to that entire network stack again, and they can do anything out of that. So there's a need to reduce elements inside my containers as well. You don't need arbitrary cat command, ps command inside my container. I'll talk about like why seemingly innocent applications can also turn out dangerous any day. So this is what ChainGuard does. ChainGuard has its own images, which they say is a minimal version of, like, there's a Python image and there's a ChainGuard image. And just, yeah, sorry.
ये system calls blocked होती है या application ही करते जैसे कोई भी extra command के लिए?
Like, it depends. So like at the end of the day, I've not talked about system calls yet. System calls block. We have not talked about system call blocking yet. What we have been talking is reducing the layers inside the application such that system call करने वाला कौन है. मेरे application का तो मेरे को पता है कि क्या क्या करने वाला है. But मेरे application के अलावा जो binaries है मेरे container के अंदर, I don't know what it's going to do. And that's what this helps out in. So as I said, like, just reducing the amount of like systems package dependencies inside my container. These are the existing vulnerability count that the container had, and they claim it as to be 0. It might not be 0, but it's still at a very minimal. How many of you know about bash as a shell? Quick raise of hands. Everyone knows, right? That's something I'm going to assume. So bash seems like an innocent, right? Bash में क्या ही कर लोगे? Bash में क्या कर लोगे? But नहीं, sudo भी नहीं है. Imagine sudo भी नहीं है. Sudo is a separate binary. Just talking about bash. Bash had a vulnerability for 30 years, and it was patched in 2014. It's called shell shock. And you don't know that how many times it was actually exploited by attackers. There's no statistics out there. But apparently that shell shock vulnerability, it did something like sudo that, okay, even a normal shell could elevate its permission and use the SUID bit. So that's what the problem was. And it was patched back in 2014. But imagine the vulnerability existed from 1982 to 2014 and no one knew about it. So that's the kind of thing, like, okay, a seemingly innocent application can turn out like you'd never know, but it's probably vulnerable and causing attacks to your system. One more vulnerability, 2014 तो बहुत पीछे हो गया. It was 2 days back, 2 weeks back. XZ vulnerability. Everybody, like people have.
0.5 second का था extra, मतलब delay.
Exactly, 500 ms के. Exactly. So the vulnerability in that was that XZ used everywhere. Even Linux packages are compressed through XZ. And what one of the maintainers did is that they injected a seemingly, मतलब एक लाइन का कोड डाल दिया. 512 कैरेक्टर का कोड था, but it was actually a binary execution thing, and it could hijack your kernels and like SSH passwords leak कर सकता था, and a lot of things it did. But at the end of the day, it is being used by everywhere. But just like, so that's a main concern, that you never know which existing seemingly innocent application can turn vulnerable and can start causing attacks to you. So that's why it's important to take an approach that don't trust anything and try to reduce, like, okay, ये चाहिए तो मैं रख रहा हूँ, नहीं चाहिए तो नहीं रख रहा, कभी काम आ जाएगा इस सेंस में नहीं रखना इसको. So that's the approach, and that's the reason you should choose lightweight images. Just by removing, like, choosing your base image from Ubuntu to Alpine could probably save you hundreds of MB in your container image size itself, but it can probably save you from thousands of attacks that can happen in the future as well. So that's an important angle. So someone asked me about syscalls, right? So containers themselves, we talked about how we can reduce entities inside the container, but still, what about the entities inside the container, which I absolutely need? Like XZ was something I absolutely needed. So how can I limit the attack surface that, okay, all sort of accesses it can have, what sort of capabilities it can call, what sort of network? Okay, we talked about an application that, okay, I have a Python application, I have a database, it needs to communicate with each other. That's fine. But XZ binary inside my application would not ever need to access network, right? Because it's just meant for compression. Its only job is to compress things, like encrypt and compress things. So it does not need to access the network system call. So probably that binary should not have to access to the network entities, and you can fine-grain access control that. I'll not go into deep into how to do that, but these are some of the capabilities that out there, like Kubernetes security context. You can define AppArmor profile, seccom capabilities. You can define service mesh, network policies, a lot of things out there which help you achieve this. But there's a need to understand that why we needed to do this. I talked about trimming down application. So Docker Slim is one of the tools which can help you trim down, because just choosing a base image might not be enough. You might need to use something like Docker Slim to reduce your image size, contents as well. Let's zoom out a bit. We have been talking at a very fine grain ki haan theek hai, container ke andar kya ho raha hai. But there's a very large surface area that's humans. We humans. We as a humans can be engineered to attack as well. एक किसी को ले लिया, 2 बियर पिला दी, and now he's like सारे पासवर्ड बता दिए मेरे को, तब क्या करोगे? You cannot do anything, right? So we at an enterprise level, you have a lot of API. Like we talked about Kubernetes API server, there's a Docker API, production. Even inside our clusters, there's a production, staging, development namespace. You might not want everyone having access to everything. So this usually happens in startup. One of my friends was working at a startup, and he said that I want a specific cluster with so and so specification, so and so node images. DevOps वाले ने बोला password पूरा पकड़ा दिया कि खुद ही बना ले. So that's something that happens, and over provisioning of resources is a bad thing, and you need to think about that perspective. So we understand. So that's why role-based access control exists, and you need to understand what role, as a developer, I should not be having access to Kubernetes API, Docker API. I just want to deploy my container, and that's how. And I want to check the health of my development application. कि हाँ ठीक है, कभी prod फटा तो मेरे को पता दे कि ठीक करना है. But I don't need access to manage the entities inside my container cluster. I'll talk about an attack here now, like which used this social engineering and it had happened. So Uber social engineering attack. Have you heard about Uber social engineering attack that happened? Nope. No one? Nice. Yeah. So what happened was, so I'll talk about a bit about security. Uber is a big company. They have very strict, stringent security protocols. But what they did have was they had a perimeter security approach. So all of their entire organization is inside a VPN. So, okay, you know that outside VPN, no, like outside organizations, no one can access it. And even their VPN is protected through MFA, like multi-factor authentication ki 2 OTP आएंगे, TOTP hai, like a lot of access control mechanism that they have implemented. But now social engineering is similar to like I talked about. You get your friend drunk or like just seemingly talking and you understand that उसका phone देख लिया, phone पे password आया होगा, मैंने copy कर लिया. And there are a lot of ways to think about social engineering attacks. I'll not go talk about that, but someone did a social engineering attack and got access to the VPN itself. That a friend of his got like he social engineered him and got access to the VPN. But now because Uber had a perimeter approach to the security, inside the VPN he had access to all the file systems out there. Even though they had privileged access management, like PAM is used to manage passwords and a lot of things across organization. But what Uber missed out is that one of their shell script had admin password to the PAM itself. So now the attacker got access to the privileged access management plane and they wreaked havoc inside the cluster now. So I'm not someone who can teach Uber what to do, but if probably they would not have, they did have rbac, but as a user, they should not have allowed access to these script files to everyone inside their organization. They should limit some kind of access control to that. And that's what rbac is about. And that's why it's important to implement rbac. So one of the things to do is you should always think that you are going to be so the question is, what if we are already compromised? It's never about what if. It's always about what are we going to do when we get compromised. We should always think that we are going to be compromised and access control according to that. You never know, some friend today turns to foe in the future. So that's something you cannot actually predict. So that's the reason that you need to enable access control inside your clusters as well as inside your containers. A lot of approaches here. Just zooming in again, that we talked about rbac for humans. What about rbac for entities inside the containers? I already mentioned that how XZ does not need access to network. And XZ probably does not need access to secrets or kernel exeq calls as well. So how do we access control these entities? The first step is that you need to understand what XZ is doing. So you need to set up observability. I have an observability t-shirt on as well. So it's a Fluentd t-shirt, but you need to set up observability. You can use security modules to implement that fine-grained control over thing. There are some user space mechanisms as well, LD preload, ptrace. I'm not going to talk deep into that, but just for information that, okay, I need to access control, what the approaches we can take. That's the approaches that's out there. To set up observability, there's Falco, Tracy. These are CNCF projects, and you can utilize them to check observability. Linux security module, pod security context has support for AppArmor as well as Linux, as well as SecComp. You can utilize them. KubeArmor, I'm a maintainer of the KubeArmor project, so I had to plug that in. And it can help you ease out the management of Linux security modules. It under the hood uses Linux security modules, but now you can do it in a Kubernetes native way, defining just plain YAML files. And that's how you can have access control. So yeah, final conclusion. Minimalism is the key to cloud security. Nay, I have more. I'm not going to be so minimal about our conclusion. So just to expand, you need a multi-layer approach that, okay, node pe bhi karna hai, you need to have a security at container, you need to have security at human stages, inside containers, a lot of levels. And you need to have that level across your stack. And that's how minimal node images and runtime infrastructure, just perimeter security around something is not going to help. You need to understand entities inside any application, and minimizing attack surface outside and inside containers you can do that by reducing. Yeah.
ये कोई template रखी है?
And couple of things. So, this slide hai. Shameless pitch, but you can go to CNCF Tax Security. They have published white papers. Kubernetes 6 Security has also published white papers. You can check that out. They like people try to do, they cannot do this, but they try to have 100% coverage of what tax security recommends. There are multiple compliance frameworks out there, MITRE, CIS. So I talked about how in the first Rocky malware, how someone copied to temp directory. And CIS recommends that temp directory itself should not be executable ever. And anything should not be copied out of temp. So there are certain recommendations out there, and always following them. And compliance are something that everyone chases.
The thing is, the node packages do access the temp library, like for caching and stuff.
Yeah. And that's up to nodes, right? Like I'm not trying to read writing and executing are different. Temp is not meant for execution of things. So that's what I was suggesting, that just removing the X bit from temp directory can help you out a lot. And that's something that CIS recommends as well. So yeah, that's all. Thank you. That's QR to KubeArmor.io. I'm Barun.cc. You can find me on Demon1024 on all platforms, LinkedIn, Twitter. Is there time for questions? Yeah. Or we can take questions during networking. I'll wrap this up. Thank you. You have 5 minutes. Any questions?
Like you mentioned, this is like through like DIY of like if we go with the like managed security, so like how we can do the change, see the change if I follow the compliance and audit, like all security like roles for whomsoever people in my organization or to the client who is a guest user in my environment to see changes, to have access to their products or whatever. So like what approach do you say? As in DevOps engineer, like or what?
Okay, so couple of things. Even if you're using a managed provider, some of the things I mentioned it's up to you. That something like node images. By default, Azure still suggests Ubuntu as a node images. So going to that selectively choosing the security like image is going to be an issue. AWS also by default recommends as like Amazon Linux too, but maybe Bottle Rocket is much better at security. Google by default uses container optimized OS, so that's good for you. So those are some of the things. And as an application developer, choosing a base image is also going, like sandboxing your application is up to the developers as well. So those are something, even if managed provider, you use a managed provider, those are something you need to handle yourself. About RBAC, I believe most of the, like some managed providers do, like for AWS, there are tooling out there which show that there are Kubernetes and we work at Accuknox, so we have developed a KIM tooling for KIM. It's Kubernetes Identity Entitlement Management. It shows you what's over provisioned, what's under provision, and there are a lot of security tools out there which also do the same. So probably if you want everything managed, going to a security provider is going to help you out a lot. Or looking for those tools which help you. You can find a lot of tools in the CNCF landscape as well. I don't have it on top of my head. I'll need to check that out to help you. So hope that answers your question. Okay. Thank you all.